Good morning, children. Today we will study irrational numbers. We have already done rational numbers in the previous class. So, what are irrational numbers? Irrational numbers are those numbers whose values cannot be calculated or whose values cannot be determined accurately. For example, the irrational numbers would be under root 2, under root 3, under root 5, under root 6, under root 7 and so on. Because the value of under root 2 is 1.414 and so forth. We cannot determine the value of under root 2 accurately. Therefore, any such numbers are called irrational numbers. They are represented with the letter Q with a bar on the top. Now, when we have to express irrational numbers as decimal expressions, so we can say all non-terminating and non-repeating decimals are irrational numbers. I told you in the previous class that for a rational number, the decimal must be terminating or it can be repeating. However, for an irrational number, if the decimal expression is non-terminating and non-repeating, then those decimal numbers are called irrational numbers. For example, we can write 0.01, 001, 0001 and so on. Now there is a pattern here. We have 1 0 then 1, 2 zeros then 1, 3 zeros then 1, but it is not repeating, because when we discussed repeating, it was something like 1 1 1 1 and dot dot dot, wherein after the decimal point 1 was repeating, which is not happening here. Okay, I can have another example as 1.02, 002, 0002 and so on. So all these numbers, they are neither terminating nor they are repeating. So all such numbers are called irrational numbers. Now the first type of questions that you may get is something like write 3 irrational numbers between 2 and 3. If I have to write 3 irrational numbers, it is always a good idea to form the similar sort of a pattern. So the number between 2 and 3, one of the numbers can be 2.01, 001, 0001, 0001, 00001 dot dot dot. So this is an irrational number which is between 2 and 3. The second can be 2.02, 002, 0002, 00002 dot dot dot. This is the second irrational number. The third we can write it as 2.03, 003, 0003, 00003 dot dot dot. So these are the 3 irrational numbers between 2 and 3. We can go about writing infinite numbers between 2 given numbers. Let's take another example. Suppose it says write 3 irrational numbers between under root 2 and under root 3. Now, the value of under root 2 is 1.414. This is an approximate value, and the value for under root 3 is 1.732. So, I have to write 3 irrational numbers. So, we can write the first can be 1.4. Now, any number which is greater than 1.414 can be 1.422 00 2 2 0 0 0 2 2 0 0 0 0 2 2 and so on. The second can be 1.4303 003 0003 00003 dot dot dot. The third can be 1.501 001 0001 00001 dot dot dot. So we can write any numbers in the same format, and which is between 1.414 and between 1.732. So these are the three irrational numbers between under root 2 and under root 3. Now the question which is asked in the council exam is to prove a given number to be irrational. There are two ways of doing it. One by calculation, the other is the contradiction method. We will be using the contradiction method to prove. Suppose it says prove under root 2 is an irrational number. Herein we will be using the contradiction method to prove under root 2 to be an irrational number. So we first of all assume that under root 2 is a rational number. So I'm assuming that under root 2 is a rational number. So a rational number can be written as P upon Q, where Q should not be 0 and P and Q are co-prime. That is, they do not have any common factor except 1. Now squaring both the sides, and this is the method that we will be using for all such type of questions, squaring both sides. We get 2 is equal to P square upon Q square. This can be written as P square is equal to 2Q square. Now P square is equal to 2Q square means 2 divides P square. Because P square is a multiple of 2, so I can say that 2 divides P square. This also implies that 2 divides P. Now if 2 divides P, so P can be written as 2m, where m can be any integer. Again squaring both the sides. I get P square is equal to 2m whole square, which turns out to be 4m square. Instead of P square, I can write 2Q square is equal to 4m square, or Q square is equal to 2m square. This also implies that 2 divides Q square, which further implies 2 divides Q. Now from this we get that 2 is a factor of P and Q. So this implies that 2 is a common factor of both P and Q. But as per our condition, P and Q are co-prime. Hence, our assumption is wrong, and thus it implies that under root 2 is not a rational number. So this is the method that we will follow in order to prove any number to be an irrational number. We will discuss one more question in the next video. Thank you.